Good day, students. Welcome back to Scholars Universal School Online. This is Mathematics, and today we are going to continue with the topic matrices. In the last edition of this class, we were able to go into introduction of matrices, and we're able to work on the addition and subtraction of matrices. So today, we'll be working on the multiplication of matrices. Remember to subscribe free to our YouTube channel. Multiplication of matrices. There are two types of multiplication in matrices. We have what we call scalar multiplication, and we have what we call vector multiplication. First, let us go to scalar multiplication. So the scalar multiplication is when a number, just an ordinary number, is made to multiply a matrix. If M, for example, is a matrix which is defined as N multiplied by matrix A, B, C, D. We assume that the element of the matrix is A, B, C, D, and M is N multiplied by the matrix A, B, C, D, and N is an ordinary number such as 1, 2, 3, it can be an integer and can be a real number. Then M will be equal to AN, BN, CN, and DN. It simply means that you have direct multiplication of N multiplied by A, AN, N multiplied by B, BN, N multiplied by C, CN, and N multiplied by D is DN. For example, if we are asked to multiply 3 by the matrices 5, 2, 8, 1, then it means we have 3 times 5, 3 times 2, 3 times 8, 3 times 1. So let us see how it works. You now have 3 multiplied by this, which is same thing as 3 times 5. That is, this 3 is multiplying this 5. Then we have 3 times 2. This 3 is multiplying this 2. We have 3 times 8. This 3 is multiplying this 8. And we have 3 times 1. This 3 is multiplying this 1. So the answer is 3 times 5 is 15. 3 times 2 will be 6. 3 times 8 will be 24. And 3 times 1 will be 3. So the answer, when you do a scalar multiplication of 3 by matrices 5, 2, 8, 1, you have 15, 6, 4, you have 15, 6, 24, and 3. So we have to have an example again, like we have this. So this is the earlier example, and let us see how it goes again. So you have it, and this is your answer. So just like the one we did earlier. So this shows another example, but in this case you are multiplying 5 by the matrix 3, 4, 2, 6. And you have 3, just like we did the other time, 5 times 3, that's 5 times 3, 5 times 4, 5 times 4, 5 times 2, 5 times 2, and 5 times 6, 5 times 6. So your answer will be 15, 20, 10, and 30. I hope with this, you can understand what we mean by scalar multiplication of matrices, which is just the direct multiplication of a matrices by a number, or direct multiplication of a number by a matrix. Let's now go to vector multiplication. Here, it involves two or more matrices. But usually at this level, we only consider two matrices. Recall that in the scalar multiplication, we use an ordinary number and a matrix. But here now, we are having two matrices to be used in vector multiplication. Let us see how it goes. So if you have M equals to A, B, C, D, that's matrix A, B, C, D, and P equals to matrix E, F, G, H. Now, what happened here is that by the time we want to multiply this by this, let us see, we have to multiply M multiplied by P, which is same thing as, so if you are multiplying this, A and B will multiply everything you have here, and C and D will also multiply it as well. So, but let us take it one by one. This A multiplied by E. Can you see that? And B multiplied by G, which is this. So A multiplied, so what the first number you have here will be the addition of when you multiply this row by this column. So A multiplied by E will give you AE, B multiplied by G will give you BG. So A multiplied by the first number on the column, B multiplied by the second number on the column, which is G. So what now happens here? We'll also use this to get what should be here. It means that A will multiply F and B will also multiply H. So let us see, A will multiply F here, B will multiply H. This A multiplied by F, B multiplied by H. So you will see, please be patient and ensure that you understand this very well. Just look at the first row of the first matrix. We'll multiply the first column of the matrix. Can you see that? Then the first row will also go and multiply the second column of matrix P, which is the second matrix. So that's why we say A multiplied by E, B multiplied by G. A multiplied by F, B multiplied by H. Now, the number that will be under here, in the lower row here, will now be multiplication of this. Just as we did for the upper one, we'll do it for the lower one too. So this one will now be C multiplied by E plus D multiplied by G. Let us see how it goes. And we'll also use it to multiply this, which is C multiplied by F plus D multiplied by H. Can you see? In getting the numbers up here, we use the upper row here to multiply these two columns separately. And in getting the lower numbers, we use the lower row here to multiply the two columns separately as well. And we have this. Now let us have a practical example. Let us have a practical example of this. So let us assume that you have A equals to this and B equals to this. And you have to find A times B. That is, matrix A is defined by the element 5281. And matrix B is defined by the elements 4, 7, 6, 3. Recall that the numbers there are what we call elements. Now you have to find A multiplied by B. So let us see how it goes. A multiplied by B will give you the element 5281 multiplied by the element 4763. Then we can have it this way. Now, if we want to get the first number here, we must use this one to multiply this and this to multiply this. So 5 will multiply 4 plus 2 will multiply 6. Let us see how it goes. So this is 5 multiplied by 4, 2 multiplied by 6. And to get the second number that will be here, we'll still use the first row here to multiply all the second numbers in the second column here. That's the element in the second column. So let us see. You have 5 multiplied by 7 plus 2 multiplied by 3. And to get the numbers that will be here, that's the element that will be in the second row here, you will multiply the second row of A here by all elements in B. So let us see how it goes. The first one here, 8 multiplied by 4 plus 1 multiplied by 6. That's what we are going to have. And for here, we are going to have 8 multiplied by 7 plus 1 multiplied by 3. And that is what you have. So, all these 5 times 4, 20, plus 2 times 6 should give you what? Should give you 32. So let us see how this is. This one becomes 5 times 4 is 20. 2 times 6 is 12. 5 times 7 is 35. 2 times 3 is 6. 8 times 4 is 32. 1 times 6 is 6. Then 8 times 7, what would that be? We have 56 plus 1 times 3, which is. So here, we can now have 32, and here, what do you have? You have 32, you have 41, that's 35 plus 6, 41. Then you have 37 here, so 37 will come here, sorry, 38. 32 plus 6 is 38. Then you have 56 plus 3, which is 59. 59 will be expected here. And with this, you have been able to multiply the two matrices A and B. So, assignment for you, you take the new general mathematics for SS3 and work on page 66, exercise 8B, question 6 to 10. But before you go, in addition to this assignment, you are going to show whether matrices A and B that are multiplied here can be commutative under multiplication. If you want to do it as being commutative, you want to know if it is commutative, you will now say, you now find B times A. This is A multiplied by B that you have found. You will now do B multiplied by A. By the time you do B multiplied by A, if your answer is still 32, 41, 38, 59, then you know that they are commutative. But if there is difference in the answer, then you will conclude that A and B are not commutative under multiplication. So you have to show whether A and B are commutative under multiplication or they are not commutative under multiplication. So thank you for listening to us. Thank you for listening to us at Scholars Universal School. And thank you for learning with us as well. Remember to subscribe free to our YouTube channel. Remain awesomely blessed.